the meantime, let's move on. Topic number 2 for today's presentation. It's my pleasure right now to welcome the next presenter on this second challenge. Optimizing production lines for mold manufacturing. So I'd like to welcome our presenter from ARTC, I believe is Chuan Shen. And Chuan Shen will be presenting together with our representative from Omnimo, Simon Tan, coming up later on. Chuan Shen, please take it away.
Thank you. Thanks, Billy. Hi everyone. My name is Chuan Shen from ARTC. So today I'd like to share a bit more about problem statement 2. How might we optimize the planning of production lines so that it is flexible, agile, and sustainable in the long run? Next slide, please. Yeah. So the problem statement sponsor for this problem statement is Omnimo, and Mr. Simon Lim will let you know more about Omnimo later. So first, I'd just like to give a bit of background about what this the context of this problem statement. So let me first start off with describing the process of plastic injection molding, which is the primary process that's behind this technology that we are trying to solve. So plastic injection molding is a manufacturing process that is used to produce plastic components in large quantity. It involves injecting molten plastic resin into a mold and allowing it to cool and form into a product. So the first step in this process is user requirement specification. It involves receiving part requirements such as product details, material type, and production volume from the customer. The next step will be to design and fabricate. Design engineers will proceed to design the mold based on product design provided by the customers. Then the engineer will need to design cooling channels, the ejector pins, and injection gates, etc. into the mold so that the plastic parts produced will be according to the customer specs. The third step is the molding process itself. The molds will be tested and then handed over to the operations team for mass production of the plastic parts. So finally, once the parts are produced, they are being post-processed. Various techniques, including like ID marking, visual inspection, machining, deburring, etc., may be required on the parts that are being produced. After they are completed, the parts are packed and sealed in boxes before shipping. Yeah, so this is the overall process of how a plastic part is being produced via the plastic injection molding process. So I'll just like to touch a bit on the challenges that manufacturers of these plastic parts face. From this, we can tell that it's important to plan and develop the automation of the production line, because an optimized production line will enable the manufacturers to turn around more quickly and stay competitive in the industry as well. So number one, the challenge is that it's a manually intensive and time-consuming process. As each product consists of various parts with different shapes and sizes, it usually takes up to 2 weeks to plan and design an automation line. The lack of a standardized platform also makes it difficult for the team to perform system integration between different automation modules. So the team is also unable to compare reference molds that were produced in the past so that it helps them improve their efficiency. So number 2, the lack of an overview of the production lines. So as the production lines are being designed, there's no process to allow for a simulation to be done to create an overview of the actual production line before it's being built. So this makes it harder to determine whether the production line will work smoothly with the number of processes involved. So number 3, the lack of flexibility in the production line itself. So once a production line is planned and built, it is fixed based on its design and the molding processes that we put in place. So it makes it difficult to modify when a specific process or part is no longer required in the production process. So the result is that we have to shut down the whole system to redesign the production line, and this will cause a huge amount of wastage. And then finally, for number 4, the lack of visibility across production lines as well. So when each production line is built, it's dedicated to a single project. So when the production line is shut down due to either like when the project is being completed, or if let's say if there's a change in the client's request, the entire production line becomes obsolete. So the manufacturer will be unable to reuse the components that could possibly be used for other production lines as well. So this could lead to more wastage. slide. Yeah, thank you. So due to these challenges, I think we are looking for solutions with the following features. So I think there are three main features that are what we are looking at. And on the overall, the solution should reduce the effort and time taken to plan and produce the parts to improve efficiency and also reduce wastage in the production floor. So first, we are looking for a solution that can automatically identify potential challenges that might occur during the production phase. For example, based on simulation, like digital twin and the likes. And the solution could also predict problematic mold designs and inefficient production processes given the design constraints. So second, the solution may also be a smart recommender of sorts of the production line automation based on the customer requirements. So it may provide recommendations on the most optimal way to create a production line with automation based on a database which contains historical and current information, such as a library of materials or existing components that were already created in the shop floor. So this recommender may also perhaps suggest suitable production automation modules to allow for modularity in the production line and also flexibility as well. So the solution should be able to analyze within the production line itself and also across different production lines to recommend the most suitable manufacturing techniques, especially when an existing production line will be decommissioning soon. This will help us to save material, time, and also reuse manufacturing components that were developed earlier. So the design integration of various manufacturing techniques and processes should also be easy and user-friendly for the operators to implement. Yeah. So this comes to the end of my sharing. Thank you very much. I'd like to pass the time to Mr. Simon Lin, Senior VP at Omnimo, to tell you more about Omnimo.
Yeah. Hello, Simon. Can you hear us?
Yes. Can you hear me?
Yes, Simon.
Yes.
Yeah.
Okay.
Loud and clear.
Good. Yeah. Thanks, Johnson, for this very good, excellent run through of our process. You have paint rightly all the challenges that we have in our industries. Okay, so and I would like to I will just start with my presentation. Okay, I'm going to share with you guys the presentation. Okay. First of all, maybe just to enhance what Johnson has run through, I just want to play a very short corporate video, which is only 2 minutes, and that will allow you to have a better appreciation of how our production looks like and what kind of challenges we have. Okay, all right, and I'm going to see. Okay. Wait. Okay, hold on. I have a little bit of difficulties here.
No worries, Simon. This is very common across all the Zoom webinars we've had. Yeah.
Yeah, because there's too many.
Yeah. Okay. So it just says that Simon has started screen sharing. So we're still waiting for the screen. Oh yes, yeah. You can see the slides already. Yeah.
Okay.
They look beautiful.
Maybe can you see?
Yes, we can see the slides.
Okay.
Yeah.
Can you see? All right. I'm going to run video. Let me know you're seeing a video. Okay. Yeah. It's challenging. Can you see the video, or are you just hearing the sound?
Yeah. It's just a white screen right now. Yeah, we hear a bit of sound, yeah, but it's just a white screen right now.
Okay, we are facing a little bit of our internet the bandwidth problem this today, and I'm not sure whether it will show up nicely. Okay, are you guys able to see the screen?
No, we just see the white screen, but we can hear a bit of sound.
Yeah, I guess it's due to the.
That's possible. But in that case, you already have your slides, so maybe we can fall back to your slides to carry on. Yeah.
Okay, can you see?
Oh, yes, I see. I see a video already. Yeah.
Okay,
okay. Drone flying.
So it's a 2-minute video that gives you. Yeah.
A desire to create, to improve, to shape the new. Today, there are thousands of ideas requiring precision engineering solutions to bring them to life. Headquartered in Singapore and with over 30 years of experience, Tech is now one of the world's leaders in precision plastic engineering, design, fabrication, and assembly of plastic products across multiple industry sectors. At Sunningdale Tech, we take a proactive approach to planning the most efficient production strategy with all our customers. Our design and engineering teams then transform complex product designs to precision using state-of-the-art computer-aided software before transitioning to manufacturing using advanced toolroom machinery. Through continuous investment, Sunningdale Tech currently has over 1,000 molding machines, ranging from 10 to 1,800 tons. We provide the broadest range of molding capabilities to continuously achieve optimal value solutions for our customers. By matching the appropriate molding technology with diligent planning, we ensure consistently high-quality products while reducing waste and keeping the high standards we set ourselves. Sunningdale Tech provides a full suite of finishing and assembly services, from complex component assemblies to high-value finishing. We engineer all the details that make the product as perfect as it can be. Our quest to deliver product of the highest quality through a systematic approach has enabled us to achieve the most stringent industrial certifications and remain one of the leaders of precision plastic engineering, providing our customers with the tools to be experts themselves. At Sunningdale Tech, we look for better ways to bring ideas to life. Sunningdale Tech, molding our world precisely.
Okay, so this is our corporate video, and I'll go into the part that I will explain, the challenge, on this automation. So, imagine with me now, the automation can be like a Swiss knife, so flexible, so versatile, so deployable, so convenient. And in the manufacturing world, it's almost like a plug and play thing. It's always ready with all the tools and all the things that you need. And this particular Swiss knife that's in front of us right now is a very good example of how, if automation can be something like this. Okay, so now if you look at these are all the different hardware and PLC, the software behind all the automations. I mean, I pull as many as we can on the slide, but there are certainly countless components that are needed to integrate into to kind of put together and form a automation. And often these parts are a little bit like a Lego thing that we need to put them together. And now with that same concept of using Swiss knife as an example, and I like you guys to imagine again, isn't it wonderful if all these automation components can be integrated into easy deployable plug and play modules to have the same ever readiness like a Swiss knife. You know, this ever readiness is my terminology. In fact, my engineer Singyi told me that this is not quite grammarly correct. But I told her I want to use this because it's like ever ready battery. You know, you remember this ever ready battery? This guy never run out of power. You know, that's the name of the battery. So this ever readiness Swiss knife concept of automation is what I would like to kind of give the companies to the startup companies to have this challenge about what if we can do all this, you know. So, and it really is about quite thinking it big, you know. So often great innovations are born out of big imaginations and the dariness to dream the impossible. That this term kind of come out when I told Singyi. I recently someone would send me a video about Tesla. You know, Elon Musk making the e-vehicle, the Tesla chassis by using one piece die casting. The car chassis by die casting it into one single big piece of kind of thing, and it is quite really quite nice to really look at how that can be made possible. In fact, that means to say that one has to really build a very different die casting machine that has never been even dreamed of almost. And so this is a kind of challenge and the kind of thing that I like the startup to imagine. Okay, that's all I have. A very short slides and presentation, and I will be ready to take on any questions if there's case.
Okay, thank you very much, Simon, as well as Chuan Shen. We're going to move on to the Q&A for this very interesting, the smart manufacturing line challenge. So I have questions from the floor right now. And Jose, welcome back. And Jose is saying, okay, Jose's first question for the panel is: are mold process parameters such as temperature, pressure, or time, etc., already optimized prior to the automation? What do you guys say about this? Chuan Shen and Simon, would you like to answer this?
I would say that yes, when we go into automation, there is more or less the downstream part already. And you're right, the molding process itself, the process has to be optimized in that sense, yes. And because typically what we do is that once the mold is built, we will go through a series of validations. That validations will include us fine-tuning the process, optimizing it, making sure that the parts meets dimensions and specification. That are the things. Then we will further down into if there's downstream integration of automation that are linked to the machine. That's pretty much that we will have to do. But yeah, you're right. The process are quite established already by the time when we go into automation. Yes.
Yeah.
Okay. Johnson, yeah, please go ahead.
Yeah, sorry. I'd like to say that Simon had probably, I think, 40 years of experience in mold making, and in terms of all these mold processes internally, building it up from scratch. I think he has everything. I've never seen someone that has that type of knowledge and experience. So what I think he's looking at is in terms of the system, in terms of the manufacturing process from one process to another. And so how do you automate that type of capabilities and that you can build so that it's seamlessly from stage A to stage Z in that sense. Simon, if I'm correct, thanks.
Yeah. Andy, you are right. Yes. Yes.
Okay, thank you very much, Andy and Simon. Okay, we'll move on for our next question from Mr. Yong Shin Leong, and he says, thanks for sharing. May I ask if articulated robot arms are used for automation? And its flexibility is an important factor. Simon, would you like to take on this? Yeah.
Yes. Articulated. In fact, these days we also deploy collaborative robots, simply because it's easier to deploy and easier to program, and also relatively less expensive. So yes, certainly articulative 6-axis robot is something that we need to use. If we need to use when we need that kind of flexibility, yes, we certainly would like to look into that as well. Yeah.
Okay, thank you very much, Simon.
Actually, 6-axis articulated robot will be a very good option when it's necessary. Yes.
Okay, thank you very much, Simon. Okay, we'll move on to a question from ET guy. Welcome back, ET. And he's asking, how do you move molded parts to another process currently? Do you use a conveyor belt or manual moving?
Okay. If we need to move it more automatically, then usually we will have a robot that will pick up the part from the mold upon the opening of the mold. And then once the mold opens, the robot get into the parting line of the mold, and the part get ejected, and then it will be grip or suction cap or something like that will be hold by the end of arm tooling. Then it move on to a conveyor belt, or it can also move on directly into a automation system, where downstream processes are all planned for, and that kind of thing. Yes.
All right, thank you,
so
Simon.
that's how, in fact, the video you could see. By the way, if you guys want to catch that video again, you can go to our website, sunnydaleTech.com. That is our corporate website, and that's where you can catch that same 2-minute video over there as well.
Okay, thank you, Simon. So this kind of ties into the next question from Anonymous. It says, what is the current production line like in Omnimo? So if we can see that in the video, then I'm going to point Anonymous to watch the video again.
Yeah. Okay. So, but in Omnimo, okay, maybe it's kind of confusing for to some of the audience, is that Omnimo is basically a mold making company, and we are just making mold. And mold making is, by and large, steel cutting operation, manufacturing. So we have CNC machine, wire cut EDM machines that are essentially steel subsection process. Although we are also using additive manufacturing these days, and but by and large we are dealing with steel. Okay, manufacturing of the steel. Then when it goes into the production, when we say production, it is about injection molding. It's about injecting plastic into the mold that's already built by Omnimo per se. And then for there, it will then be producing the plastic components. And then the plastic component needs to be assembled, needs to be decorated, needs to have certain things, done downstream on the plastic part. That's when automation effectively will come in to make those processes possible. Yeah.
Thank you, Simon. I think we would love to have a visual tour. If this works out in future, we'd like to have a visual tour to understand better. But sounds very exciting. Yeah, sounds very exciting.
Right. You to come into our factory to have a better appreciation of how that the thing looks like. How the different processes that we have.
I will think that the shortlisted entries for this challenge, we'll probably get a chance to visit the Omnimo factory. So that sounds like a very good deal. Yeah. Okay. Coming up next from Anonymous, it says, how frequently do you make those planning and automation decisions? Is it something you do daily or a few times a month? Simon, what do you say to this?
Okay. As and when it needs, as far as the production or the product specification is required. So normally how it goes is that we will be working closely with OEMs on their new product introduction. And in the new product introduction, they would have things like, okay, they will be needs to build the mold, and then they'll talk about how are they going to produce the plastic part eventually. So that planning is usually done, at that stage, very upfront, during the during the initial part of the MPI phase, so this is done that way, and often the conceptualization is all done during the very initial part of us even cutting the steel of the mold. Before that, all this conceptual thing has to be done already. And then that's how we will get started once there's a need to do all the automation. Yeah.
Right. Thank you, Simon. Okay, just two more questions. One more from Jose, and Jose says, are the mold processes compliant with ISO 26262 bracket safety and ready for automotive requirements? Very, very technical questions from Jose today. Yeah. Simon, what do you say to this?
Okay, so I am not exactly sure what this ISO 26262, but we do have a ISO certification that are for automotive industries. And then beside, we are also ISO 13485 for medical device manufacturing, and of course the ISO 9001, in general. These are the certification that we are. So yeah, safety wise is a very big thing that we look at in our factory every day, every moment. We have a lot of safety protocol in place and so on, requirements and so on. Yeah.
All right. Thank you, Simon. Hope that answers your question, Jose. Okay, one more from Yongxin Leong, and it says, what are the processes that the articulated robot arms are used for? For example, are they used for spraying, polishing, or other uses? Yeah. Simon, would you like to take this on? Yeah.
Yes, spraying. Yes, spraying is something that the articulated robots are often used. The other thing about articulated robots, particularly from the collaborative robot point of view, they are widely used because they are very flexible. We can do multiple things and we can very easily deploy. So, my challenge that I'm trying to put up to the startup company is that we want a automations that are easily deployable, easily plug and play. And when that is possible, what happens is that we don't have to sort of reinvent the wheel each time, and it's about just put just like the Swiss knife, able to just pull out one of the tools or one of the tools that we want to use, and then we are good to go. So this is that kind of things, so especially in automation, often things are done specifically for one purpose only. Then when that particular project go into EOL, sometimes very sadly to say that the whole automation has to be scrapped away, or kind of discarded or cannot be used. Even if you can salvage some of the components, but a big part of the automation is gone. It's not deployable again. This is exactly what we are trying to avoid, and trying to see how can we make it so flexible, so deployable, so ready to use again kind of thing, plug and play. That kind of concept that we are trying to challenge the startups. Yeah.
Okay, thank you very much, Simon. I think I love your whole idea of this configurable Lego-like system. I mean, as a Lego fan, I love it very much. So thank you very much, Simon and Transhen, for this second challenge presentation.